Okay, so you are showing a sphere. Now, when you look at the side of it, any angle, you see a circle. Do you know what that circle is called?
A circle.
It has kind of a cool name. Rafa, why don't you turn on your video so you can join our class? Thank you so much for joining. Luke, can you unmute Rafa, Hannah, Claire, and Adalia? Everybody unmute themselves. I had this discussion just a few seconds ago with Elliot and Claire. There you go. There you go. It's really, really simple. Okay, now, Luke, I can only see the top of your head. Same with you, Adalia.
My laptop doesn't really.
Well, you know what? You look great. You look great right now. You look
Oh, I got
great.
it.
There you go. There you go. You see what happens when you put your mind to it, right? Now,
Yeah.
you look up in the sky, and what do you see?
The sun or clouds or the sky.
Yeah, guys, do you see any great circles?
The sun.
The sun and the moon.
Yeah, guys. Right now, I'm actually not going to show it to you because it's really too bright. But it is the great circle. And when I look at this, no, I haven't been on vacation in a long time, but my life feels like vacation because I'm in sunny places and I'm on a boat, but that's where I work. So I look at the great circle of the sun every single day. And once a month, what else can I look at?
Look at
Full moon.
Yeah, I can look at the great circle of the moon because you can't see the great circle of the moon when the moon is not full. Because it's only when the moon is full that you can see the great circle. Now, if I took a sphere, everybody hold up the spheres that they had in their hands. And if you were to chop right through the sphere, could you create smaller circles?
Circles or spheres?
Circles. So let's say you took a sphere and you started cutting cross sections with a knife. Let's say your sphere was, let's say, a ball of dough, and you started to cut cross sections. Wouldn't each cross section be a circle?
Yeah.
And couldn't I actually do that an infinite number of times?
Because they're still a part of a circle.
So what then is the great circle? Who can describe that? Raise your hand. Raise your hand if you can describe the great circle. So I don't see Hannah anymore. Adalia, I only see the top of your head. I now see Rafa almost the top of his head, but a little bit more of Rafa. It's great. Claire, would you like to describe how to find the great circle when there's so many, and there's an infinite number of circles that can be cut through every sphere?
The one with the biggest diameter.
That is exact. You know what? I don't think I could come up with a better definition, Claire. That's exactly right. The great circle is the circle within a sphere with the greatest diameter. So guys, hold the sphere with two hands like this. Hold the sphere in between. I'm going to use my head as a sphere. I see Adalia has like a little marble or a bouncy ball. Rafa, I see Hannah's. I see Luke is using his head. What about you, Elliot? There you go. Do that with yours. Excellent. Now, if you measured the distance of your two hands parallel, that would be equal to the diameter of the sphere. It's actually very difficult to measure because what you have to do is you have to take that and then you have to put these up against a tape measure, and these, your hands have to be perfectly parallel. They have to be perfectly parallel and perpendicular to the tape measure. So it's very hard
Or
to actually
yes,
measure diameter. Question, Elliot?
it would be easier with something flat.
Of course. With a plate, it's so much easier. With a pie, it's easier, but a
And tasty.
sphere is not easy. Now, I want to talk about a volleyball. Does anybody here like volleyball? I
I've never
love volleyball. I love hitting balls like this, where you go up like this. And I also love spiking a volleyball where you jump up as high as you can and you hit the ball straight. And it's very hard for someone else to hit back a spiked volleyball. So let's look and see
played a
what a
little of
volleyball looks like.
We had a volleyball tournament gym.
Oh, you did?
Yeah.
Cool. So guys, a volleyball has a diameter of approximately 8 inches. So everybody look at the blue line. I am going to extend it now to a diameter. And as you can see, each square represents 1 inch. And so
That's
this
not
is
the
an
size of a
8.
real volleyball, though.
Say again?
That's not the size of a real volleyball.
Well, no, it is the diameter of the great circle of a volleyball. Volleyballs are maybe a little bit more than 8 inches in diameter. Now, what is the segment called? Please raise your hand, which is going from the center of the sphere or the circle to the outside. Adalia?
Radius?
It is the radius. Who can give me 2 formulas that connect diameter and radius? Diameter and radius. I'll put an equal sign in between. Neither of these are true right now. Can everybody please write that down and create 2 equations that connect a diameter and a radius? One equation isolates diameter and one equation isolates radius. I like both of them very much. Hannah, what did you come up with? Just give us one. Just give us one. Hannah, what do you have? Can you hear me, Hannah? Give me a thumbs up if you can. Give me a thumbs up if you can hear me.
Yeah.
Okay, good. Would you like to pass, or do you want to take a shot at answering one of the 2 equations?
I was just trying to find the page, so I haven't actually started.
Okay, no worries, no worries. Why don't I choose Rafa? How can you relate diameter and radius, Rafa?
The diameter of a circle or a sphere is twice as much as the radius.
So can you give it to me as an equation? Instead of the word is and twice as much, can you use words like equals and words like times?
The diameter equals the radius times 2.
Exactly. Diameter equals 2r. Write it down. Write it down. Luke, did you come up with the other one?
Yeah.
Diameter divided by 2 equals radius.
Exactly. Both of those are awesome. Now, I prefer to write division as fraction. Diameter divided by 2 equals radius, and diameter equals 2 radius. Both of those equations are valid. Now, where can we go from there? You guys remember, don't you, the number pi? What did we say was a great estimate for the number pi? Who can give me that? Elliot?
3.14.
Who can give me a different one? Adalia?
3 1/7.
And who can give me another one, please? Raise your hand, Claire.
22/7.
Yep. And therefore, the area of the great circle within a sphere equals pi times the radius squared. Who can define what it means to square a number? Who can define what it means? I'm going to go with Hannah.
To times the number by itself.
Yes, but how many times? How many times?
Twice.
Twice. What about radius to the third power? What would that be? That would be radius times radius times radius. What about radius to the fourth power? R. Okay. Now, I want everybody right now to write down area equals pi r squared. And if you know that the radius is 4 inches, in terms of pi, what is the area? On 3, 1, 2, 3, go.
16.
Come on, say it, guys.
16.
Times
It is definitely not 16.
16 times
Or, I mean,
Right, Adalia, it's 16 pi square inches. That's the actual great circle area of a soccer ball. However, we're going to estimate pi at 22/7. I'm wondering, guys, how many of you know how to multiply fractions? Who can describe for me the method to multiply fractions here? And I'm going to go with Adalia.
First, you see if you can cross cancel. And if you can't, you multiply the numerators and the denominators together and then simplify it.
That's a great explanation. By the way, guys, can we simplify 16/7?
No.
No, because 7 doesn't go into 16, okay? And 7 is a prime number, so no number goes into 7 other than 1 and itself. So everybody, what is 16 times 22? No calculators. I want you to all write it out your own way. And I want to know what you get, and then I'm going to ask you how you got it.
do I message it to you?
Nope.
Okay.
I would try it though multiple ways. That's what I would be really happy if you did.
I think it's 342.
342.
I got
Anybody else have a different answer?
I got 352.
Okay. Now, guys, when I do it, I get 320 plus 32. When I do it this way, I get 220 plus 132. What did I get, everybody?
530.
352.
352. Now, how many of you know the standard algorithm? 16 times 22. Only one of you knows the standard algorithm. I think Luke as well. I think today is a day we should focus. Come on, guys, everybody do it. Ready, go. 2 times 6 is?
12.
12. Here's the 1.
Do it again.
13.
2 times 1 is?
Is
Two.
2 plus 1 is 3.
So 2 times 1 is 2, plus 1 is 3. Now, this 2 is not a 2, it's a 20. So we need a placeholder, and I usually put a little smiley face. 2 times, wait a minute, do we need to do it again? Didn't we already find out that 2 times 16 was 32? And guess what?
Yay.
If we write it down, what do we get?
352.
352.
Yay.
So now, you already have 352 divided by what?
7.
And now, I want to see 352 divided by 7. Everybody go. 3 into 35, say it out loud.
5.
5.
7 into 2.
0. Remainder 2.
Wait, 2 what's, everybody?
7.
2 sevenths. Because Adalia, this is 352 sevenths, which is 50 and 2 sevenths left over. Now, I had a lot of fun creating this for you guys. Okay. Do you see how 50 and 2 sevenths? Do you see what I did? I wrote a number in every one of the squares that were what? Who can tell me what I did here? Claire?
You wrote and then run all the squares that were whole.
Now, are they exactly whole, Adalia?
No. The one like 3, 8, 22, I think it's 30. Like all the edges aren't completely whole, but they're almost whole.
Yeah, so I decided to write numbers in every square that was either whole or almost whole. Now, I got 44 of them, which means that the 8 blue sections must represent approximately what?
A whole.
How many holes? Approximately 6 holes, because 44 plus 6 is 50. And then the 2 sevenths is the little pieces, are the little pieces that are left over from mine. And it's really, oh, actually, there's another 4 little pieces. And it kind of is fun to try to look at the area of a circle and see if you can get really close to it. Yes, Adalia, question.
I think there might be one more incomplete square, 30.
30. Oh, yes, you are correct. So there are actually 8 incomplete squares. No, that's not true. How many are there, guys? Hannah, how many did you count?
I think 12.
Very good. There are 12 incomplete squares. Very, very nice. Now, I want everybody to go to page 6 in their packet. And what I'd like you to do is I would like actually for you to choose what would be one of your favorite sports balls that we could figure out the area of the great circle. Who wants to start? Okay, go ahead, Hannah, and then Dahlia.
A soccer ball.
Say it again, honey.
A soccer ball.
Soccer. Adalia,
Also soccer?
good. Claire?
Beach ball.
Anybody else? Go ahead, Elliot.
Baseball.
Ooh. Now, I don't remember exactly what was the diameter of the beach ball, Claire.
I forget. I check in the other packet from last week.
Yeah, look at the other packet. Dahlia, do you know?
Wait. No, it's not on this one.
Yeah, I don't think it is, but I thought it might have been 2 feet.
There's a beach volleyball, but that's not a beach.
Now, I do have to say, guys, the full disclosure is that beach balls can be different diameters, right?
Yeah.
There's no regulation beach ball. The same way that there's a regulation baseball, a regulation soccer ball, regulation volleyball, basketball, etc. So let's go with 24 inches.
Mm-hmm.
Okay, everybody say it on 3. What is the radius of this beach ball great circle? On 3, 1, 2, 3.
12 inches?
12 inches.
And now, everybody write down area equals pi r squared. And now your job is to use 22/7 and find out the approximate area as a mixed number of the great circle of a beach ball. So get working, guys. And I'll work on this a little slower. So if you want to look up, you can. If you don't want to look up, just record your radius at 12 inches. Record your formula, which is area equals pi r squared, and get going. And if somebody has a question about how to do the standard algorithm, go ahead and ask it now. So if somebody has a question, this would be a great time to ask.
For 144 times 22, I didn't get 3,168.
You did not. Tell me what you got.
I got 3,124.
3,124. 24. Now, can I ask you, Claire, how did you do 144 times 22? What was your method? Did you use distributive property?
I just like broke the numbers up and did it.
Well, you mean you wrote 22 144 times?
No, like I
No.
did like 140 times 20, and then 140 times 2, and then 4 times 22.
No. What you've got to do is you've got to do 144 times 20 plus 144 times 2. Try that, Claire.
Uh-huh.
Try that. You actually can partition both, but it's a lot more work.
Sorry, my audio just broke.
Yeah, well, did you get it fixed?
Yeah, we fixed it.
Awesome. Awesome. So does anybody have a question? Claire, does it make sense why I got 3,168?
Yeah, I got that too.
Okay, great. Now, how many of you were successful in dividing 3,168 by 7? Who would like to do that together? Hannah?
Sure. Wait, should I say what I got out loud?
I'd like you to say 7 goes into 31.
4 times.
You have to always say the remainder as you say it.
Remainder of 3.
Keep going loud enough for everybody to hear.
7 goes into 36 5 times with a remainder of 1. And then 7 goes into 18 twice with a remainder of 4 7.
And that, everybody, 452 and 4/7 square inches. 452, whoops. 452 and 4/7 square inches is our final answer. Did anybody get close to that? Elliot, how about you? Elliot, you're muted. Rafa, Claire, Luke, you're all muted. You need to unmute yourself, please. Elliot, can you unmute yourself, please? Good. Unmute one more time, and there we go. Keep yourself unmuted. Go ahead, Elliot.
Yeah, I got that.
You got that. Great, great. Rafa, how about you?
I was doing another sphere.
I'm sorry?
I was doing another sphere.
Okay, but I want you to first do the sphere that we're doing, and then you can do another sphere. How about you, Luke?
I'm sorry.
How about you, Luke?
I couldn't hear any of this before.
Okay, so you didn't know what we were doing. You couldn't see from the picture.
Well, I could see, but it was just unclear because I couldn't
Okay.
hear anything.
Okay, so you really got to practice this in order to get really good at it. How about you, Adalia?
I forgot that you had to, what's the word? Square the radius. And so I realized just after I finished that I did it that way. And so I had to restart and didn't finish.
Excellent, excellent, excellent point. Excellent point. Now, let's look at baseball and soccer. Okay, so baseball is about 3 inches or 76 centimeters. Let's do the baseball, guys. Let's do the baseball and use 3 inches. But what I want to do is I want to ask you, if the baseball is 3 inches in diameter, what is the radius? Everybody say it out loud on 3. 1, 2, 3, go.
1.5.
I want you guys to get into the habit of writing down 3/2. 3/2 inches is the radius. Now, and Adalia, watch what I do every time. I write the formula, so it's like a roadmap. The area equals 22/7 times 3/2 squared. And folks, 3/2 squared is 3/2 times itself. Now, can we cross cancel? Who sees a cross cancel opportunity? Elliot, do you see one? And please unmute yourself as Rafa, as I've asked you countless times. Go ahead, Elliot.
Well, 2 doesn't go into 3.
Yeah, but 2 goes into 22.
Yes, it
So-
does.
So 22 over 2 is what?
11.
Over what?
1.
Right. And I don't think we can do any more cross cancel. So everybody do 11 times 3 times 3 over 7 times 2. Come on, guys. What is 11 times 3 times 3?
99.
And what is 7 times 2?
14.
14.
Now, if we want to get really close, 99 divided by 14,
Is.
can we simplify that fraction? Let me ask you this. What if it were 98 over 14? What could we do then?
You can.
Is that simplified?
Come on, cut them in half. Half. Come on, what's half of 98?
48 over 7.
49. 49 over 7. What is 49 divided by 7?
7.
7. Therefore, 99/14 is what?
7.
7 and is 7.
7 and 1/14
Ooh.
square inches. So if you look at the great circle, guys, of a baseball, the great circle of a baseball, you will see 7 and a tiny bit more square inches. Now, the last one that I want to do before we get to our planets is I would like to do a soccer ball. And a soccer ball is 8.8 inches. Let's write that out. A soccer ball is 8.8. And we're going to do this. And now we're going to convert that to a fraction. Who can convert? Well, actually, you know what? I'm sorry. Please write down 8.5 because that was the range. Now, give me that as an improper fraction. The mixed number is 8.5. What is that as an improper fraction? Who can tell me out loud?
9 halves.
Not 9 halves.
17 halves.
It is 17 halves. 8 times 2 plus 1 halves. 8 times 2 plus 1 halves. 17 halves is our diameter. Now, using 17 halves, who can tell me what the radius is as an improper fraction? Now, this one is really cool. It's really cool.
17 fourths.
Say again, Rafa.
17 fourths.
And Rafa is correct. All you have to do is double the denominator and it cuts the fraction in half. This is the radius of a soccer ball. Now, everybody, let's get to work. Area equals pi r squared. Area equals 22/7 times 17/4 squared. Now I'm going to ask Luke, do you see what we can do to cross cancel before we multiply?
Yes. You can cross cancel with 2s.
I don't understand though. I don't see any 2s here.
Well, 2 goes into 4 and 22.
Ah, so you're cross canceling 22/4, which is
11/2.
That's my man. Nice job. Now everybody get going. 17 times 17 times 11 over 7 times 2 times 4. And if you guys want to see my 11 out times 11 algorithm, you write the number down twice and then you add. But you have to push the second one over one place value. So if you get 17 squared, then multiplying by 11 will be very easy. Oh boy. $31.79 over 56. Okay, so does anybody have a question that they want to ask me about anything that I'm doing here? Because this is a little bit out of the box, and I'm interested to see what you guys think about this strategy.
I got 227 over 4, but what do I do now?
Well, do you see that I estimated 3,179 at 3,178? Do you know
Yeah.
why I did that?
So you could divide them both by 7.
Right. And since I
Mm.
can't simplify 227 over 4 anymore, I just
Yeah.
divided 227 by 4 and got 56 3/4.
Mm.
But then, Claire, do you see that I have
Yeah.
the 156 left over?
Yeah.
And so then I just added 3/4 to 156, and I got 43/56.
I got
And this
58.
is the exact number. So Elliot, what did you say, buddy?
I got 58.
Wow, that's really close. That's really close. What did you get for your numerator, Elliot?
56.
Your numerator, that's the number on the top of
Oh.
the fraction.
3,179.
Ah, and how did you get 58?
I multiplied it by 56.
Yeah, but how did you know to multiply 58 by 56? Didn't you divide 3,179 by
Divided
56?
3,179 by 56.
But how did you get 58?
I guess I just made a mistake.
Oh, tell me what it looks like, because I like finding mistakes is like the most fun in mathematics. So did you do it like this?
Yes.
Okay, cool. So how many times did 56 go into 317?
5.
Nice. And 5 times 56 is what?
400, no, 200 and, wait, I forget. It covered up what
It's 280.
yeah.
So the
'cause 5 times
remainder, my friend, is
280.
37.
Oh.
And how many times does 56 go into 379?
Oh, Then there's my mistake. I accidentally did 47.
Ah, you see, that's 6 times, which would be 336, and 336 and 379 have a difference of 43. 43, 56. It is so cool to find mistakes. Did anybody else make a cool mistake that they can share? Now, I want everybody to put their pencils down. Would you guys like to do as a team the great circle of the sun? Is that a yes? Is that a thumbs up? Okay, but I need to see your eyes at all times. Now, you don't need to take notes. And the reason is I've already given you all the calculations. Adalia,
I go quickly get my charger. My computer's about to die.
go for it.
There.
Now, guys, the diameter of the sun is 865,000 miles.
It is.
Everybody now
I
watch
did
how I divide by 2. Are you ready? Go, watch. 4, 3, 2, remainder 1, 5, 0, 0. Everybody in agreement?
Yeah.
Okay, now.
Yeah.
We always write out our what? Our formula. The
Yes.
area of the great circle of the sun is 22/7 times 432,500 squared. Now, everybody watch how I do that. Do you notice that there are 4 zeros to the right of this equation?
Yes.
Okay, now, since there are 4 zeros to the right of this equation, Luke, you ready? Hannah, Claire, Rafa, Adalia, and Elliot. 5 times 5 is 25. 5 times 2 plus 2 is 12. 5 times 3 plus 1 is 16. 5 times 4, 21. Placeholder. 2 times this number, well, can I just double it? 8,650. 8,600, whoops. 8,650. Now I need 2 placeholders, everybody. Are you all paying attention? Ask a question if you've got one. 3 times 5 is 15. 3 times 2 plus 1. 3 times 3 is 9. 3 times 4 is 12. Now we have to multiply it by 4. Here we go. 3 placeholders. 4 times 5 is 20. 4 times 2 plus 2 is 10. 4 times 3 plus 1 is 13. 4 times 4 plus 1 is 17. Everybody, let's add those together. 5, 2, 6, carry the 1. 5, it's 15. 20, carry the 2. 7, 8, and 1. What is missing at the end of this calculation, guys?
0.
4 zeros.
1, 2, 3, 4 zeros. We now have 187 billion, 56,250,000. Now we've got to multiply that by 22/7. Now, what we're going to do is we're going to make our life a little easier And we're going to divide this number right here by 7. It's not going to go evenly, guys. It's not going to go evenly, but we're going to use whatever estimate we get. Everybody get ready, get set, go. 7 into 18, go.
2.
2 is the remainder of 4.
6, that's
6.
What's the remainder of 5?
5. 7 remains
7.
1.
The remainder of 1.
2 remains
2.
1.
2.
2,
2.
3 remains 1.
2.
Remainder 1.
1.
4 remainder 2. 2 remainder 6. 8. And even though we have a remainder, we're going to use this number, everybody. We're going to use it. Ready?
Write it down.
I'm going to write it down right now. 26 billion 722 million 321,428. And all we have to do is multiply it by what?
22.
You guys ready?
Oh, so we're making it big again.
Let's go, guys. 6, carry the 1. Go. 5, go. 8,
8,
go.
2,
2,
4,
4,
6,
6,
4,
4,
4,
4, 14, carry the 1.
13.
13, carry the 1.
Yeah, 5.
And 5. Now, guess what, guys? All you have to do is write the same number down. You don't have to do any work. Isn't that awesome? Because you have a place value. Now, let's add them up, guys, from the right.
6,
Go. 6,
11,
1,
1 carry the
1,
1. 4 carry the 1.
1,
1 carry the
11.
7. 0 carry the 1. 1 carry the
11.
9,
9.
9,
8. 7. 8.
8.
5.
5.
Oh my gosh, guys, this is in square miles, 587. Who wants to read that number for me? Who's going to read that number? I'm going to go with Claire on this one. Go, Claire.
587,891,416.
What? Square miles.
Square miles.
Everybody, now, I want you to look outside your window and I want you to look at the great circle and look at it and go, Mom and Dad, it's 587 billion square miles that I am looking at right now.
My window's on the wrong side.
Oh, that's too bad. You need a new window. You
No,
need
I
a new
don't.
window.
There's actually too much light coming in my window.
Yeah, guys, you're really not supposed to look at the great circle, just so you
As
know.
you can see,
Even though
Because
you
right.
it can actually damage your eyes, so you have to be very careful. But when great circle is setting, it is going to set below the horizon, you actually can look at it because it's like this ball of fire. And every time I look at it, I think, oh my gosh, that's 500 billion square miles that I'm looking at right now. 500 billion. I don't think I'll ever travel to the sun, but I can
I
certainly
don't
look
want
at
my
it.
body and corpse in my bones to get melted.
Guys, it was such a great time. And I would like to know if you're interested in more of this. Maybe we talk about the volume of a sphere, which
So
is
much
the
circles.
most incredible thing. The volume of a sphere. It was discovered by Archimedes. And I leave.
They discovered volume.
Say again, buddy.
They discovered volume.
Well, right. Volume was always there, but Archimedes discovered the equations to figure out volume. Guys,
I mean,
I will
technically,
see you.
they discovered math.
Well, math has always been there. It just needs to be discovered. Luke, Claire, Adalia, Rafa, Hannah, Elliot, you guys were amazing today. I hope you practice your standard algorithm this week, and I will see you in 167 hours.
Yes.
Bye.